captions so that in case someone is watching. Jason has asked about number 4 from 3.2. So I'm going to bring that up now. So if you have some difficulties with the numbers, this is what number 4 looks like. Whoops. Wow, popular today, aren't I? Hi, Mauricio. Can everybody hear me? Are we all good? Everybody good? Okay. So as I was saying, Jason has asked about 3.2 number 4, and his question was, how much work do I have to show on this exam? And what I was explaining here is that after this first exam is over, so after we've covered chapter 4 and you've taken your first exam, you won't have to show quite this much work for the ungrouped data. But on this first exam, she wants to know that you can actually use the formula. So what I suggest you do with the calculator is take your data, and I have written the data here. Take your data, use the calculator to sort your data, and then you can use your calculator to generate the squares of each of your data points. And then you can fill in the formula that's given, okay? So it should just be a matter of let the calculator do the heavy lifting here on these for you, and then just plug it into the formula and get the approximations, okay? After the first exam, then you can just go in, enter the data in list 1, and use one var stat to get this answer directly. But for this exam, we want to see the formula. Okay. Now, Jason, did you have a specific question about this? If you need the PDF work for this, I can send it to you. Just let me know. I have the PDF. I can send it to your inbox if I'm aware of it. Let me.
Okay. I'm sorry if interrupting. Question on the homework. Do we have to do the same thing?
For a problem like this, for raw data, yes. For the group data, where you have the class limits, the class boundaries, you just need to write in the midpoint column, and then you can use the calculator procedures for that.
Okay, so just put the midpoint and just punch in the
right. So
variance and deviation.
Well, so you, as long as you show us your X and your M, there are, I made an example video of that, or a part of the example video for 3.2. I do show you an example of how that works, but if we need to go over it, I can. That's not an issue. There are a couple of issues with this homework assignment, so, and they're known issues. You'll be getting an email from Professor Nickdell regarding the answer key, because the answer key, she missed a number on it. And if you happen to watch the video from today that I posted from 3.1, there is a mistake in one of those problems. So I'm going to have to go back and do it. But she is aware of it. So does anybody have a question about this? And there is a dedicated video to this problem as well. So if you, I'll be happy to go over it more. But if you'd like to rewatch it, there is a dedicated video specifically to this problem itself where I go through all the work and I go through all the calculator keystrokes if you're not familiar with your calculator yet. Any other questions on this problem here?
Will that question go similar to number 5?
I believe number 5, is that the range rule of thumb?
It's
Is that
basically
that
saying
one?
that the scores from the last 10 years, US bowling.
Okay,
Con-
let me bring it up because maybe I'm confusing it with something else.
Because I also did that, but it looks like I might have to.
Hold on, it's not loading properly, so let me see what's going on here. Homework, screen, no. All right, this should, there we go. Number 5, you said?
Yeah.
The last, okay, so in number 5, the thing about this is there are 2 sets of data, one for men and one for women. So treat the men's as one set of data, one row, treat the women as the second row. So do the men separately and then go back and do the women. And then you're
Okay.
going to compare them for each set of data. Okay.
All right.
Who else have I got in the room that has a question? Does anybody else have a question about number 5?
No.
No. You guys can feel free to keep your mics on as long as there's not a lot of noise in the background where you are. Whether your cameras are on or off or your mics are on or off is not a problem for me, but whatever's convenient for you. Mauricio, what can I help you with?
Well, I wanted to see like questions number like 7 and 8. But now,
From 3.2?
yeah, 3.2.
Okay, all right. Sure, let's take a look. Jason, are you good for a couple minutes?
That's fine.
Okay.
I'm okay.
No problem. All right. So you said 7 and 8. What's giving us problems about that? Let's see here. Oops, wrong screen. Sorry, wrong screen share. All right, number 7. Okay, if now I happen to download the wrong, let me download the correct version of this. The correct version of this number 7 should have 12 values in it. If you have 7 values in your 9 values on your list, then you need to go back and re-download this question is the only question that has this problem. Okay, but your data set should have 12 values in it, not 9.
Okay, no wonder I was getting the wrong answer. I was like,
It should have 12. So let me see if I can bring up, because I have 2 versions of this on my desktop. The one in the video that I made does have all 12, and I tell you what they are. But if you're getting a wrong answer, that could be the reason why, because there was an error there. So
okay,
let
question
me
on that video that you uploaded, did you show how we're supposed to answer this question, like show the work? Because I'm trying to learn more to use that calculator because it's a lot quicker and less writing.
Right. I did show, okay, so for the video that I did, I showed an example, which was, I did number 4 as a separate video, and this works the same way as number 4, but with fewer data. Now, let me ask this, what I can do here, for the sake of not making us do quite as much rigmarole, does anybody happen to have, if not, I'll go back and download it, but does anybody happen to have the correct version that has all 12 values in it?
I do.
Already, you do? Okay,
Yeah.
let me do one thing here and grab the emulator, and we'll do it. We'll do it right now so you can see how it works. And I'll go through. How many of you are feeling not so good about the calculator right now? Don't be shy. Like, if you want to practice it, you can, but I do have some more video with that, but I will go through that because it does take a while to get better at. So let me right now grab my emulator from the bottom of the screen. Give me a moment to let it open. This is an on-screen version of the calculator. Let me put it up on the screen for you. And then I will show you what. Now, first of all, what I should ask you is, can somebody tell me the difference between grouped and ungrouped data? Okay. You think you know, Jason?
What was it again?
What
Sorry.
is the difference between grouped and ungrouped data?
I don't
Grouped
know.
and okay, let me tackle that first because that has to do with that is part of the big distinction here. So that's the first distinction we should make. Let me go back here. And I really, for the sake of our purposes here, this doesn't matter. When you see something like number 4, number 5, number 6, number 7, where you just have lists of numbers, okay? You don't have a frequency distribution. Does everybody understand what I mean by a frequency distribution? When you just have data, this is ungrouped data. The procedure for doing it with ungrouped data is a little bit different than if you have a frequency distribution, okay? So ungrouped data, you work with like the thing that I put up previously that I had open at the beginning of this meeting. If you have a grouped frequency distribution, such as number 9, number 10, number 11, number 12, those are frequency distributions, and those are group data. So that's where you're going to need to make that other column of the midpoints and then put in the calculator with the frequency and the midpoint. Okay. Let me go back and do the one for the data that we're missing so we can clear that up for you. Okay. So I'm going to put my calculator on the screen. And if you can go to number 7. And if somebody can make sure you have the one that has 12 values, what I'm going to do here is, can everybody see my calculator on the screen, first of all?
Yes.
Yes.
Okay, so what I'm going to do here, probably your calculator, it depends on what it looks like when you turn it on. Let me turn this off just so you can see it. So if this is your screen. Now you might have a screen that looks like this. You might have, or sorry, that was the wrong version of what I wanted to do here. Let me clear the keystroke history. So your calculator might look like this, or you might have stuff on it. It really doesn't matter. But what I'm going to do here is I'm going to start anytime, whether you're doing a grouped or an ungrouped distribution, start with the stat key. So stat, and we're going to edit it like our spreadsheet. So edit here, you can either hit the number 1 or hit enter. I'm going to hit enter here. Now I have some data entered. I'm going to go ahead and clear this. There's a couple of ways to clear this data. You can either use You can either use second, memory. Okay, memory is on top of the plus sign. And number 4, if you have multiple lists, second memory number 4. So I'm going to go down and hit the number 4 and hit enter. That will clear, that works well if you have more than one list. Because what it does for you is it clears all of your data for you at once. If you want to clear a separate list, you can. If I put in a number here, for example, let me just put something in here so I can show you. If I have a list in there and I don't want to use, what I can do is go up to the label here, highlight the label and hit clear enter. That will work as well. Clear enter will also clear it for you. So just to let you know. Now, if somebody could be so kind as to read the numbers for number 7.
355.
Whoops,
Oh,
my apologies. That was my fault.
okay.
Go 355.
94.
94.
Yeah.
Okay.
34.
34. Okay.
79.
79. Okay.
27.
27.
66.
66.
39.
39.
39.
39 again. Okay.
27.
27. Right.
22.
22 and
60.
60. And I think we have one more.
35.
35. Thank you very much. Okay, now I'm going to give you guys, I'm going to scroll through my data. And I want you guys to check and make sure that I have entered the correct numbers. Okay. So I'm going to scroll here so you can watch the data scroll by. We're good? Okay. So we're looking for the mean, the variance, the standard deviation. Okay. Now for this, it doesn't matter if your data are in order, you can sort them or not. If you don't know how to sort them, I'll go ahead and show you that now. This is an extra step for this problem, but if you're writing it on paper, sometimes it's easier to keep track of. If you want to sort your data, you go to stat. You go down on the menu to, we have 2 sorts. We have a sort A and a sort D. This is sort A. That means it's going to sort in ascending order, meaning that it's going to find the lowest number and go to the highest, which normally is what we want. We use this a lot in 3.1 and 3.2 to do a lot of our statistical measures. Sort D goes the other way, but we normally go with sort A. So what I'm going to do here is, this is, oops, I said that and then I hit the wrong key. My apologies. Stat, sort A. So here's your sort. Now we have a parenthesis, okay? And in this parenthesis, you're going to tell it which list you were in. We were in L1. L1, if you look now, I don't know about the color of your faceplate on your calculator. Mine is a gray faceplate with blue accents. So my L1 is in blue above the number 1, and my second key, if you look next to the mode key at the top left, is in blue. So anything I want that's in blue on the top of a key, I'm going to hit the second function and number 1 here. Okay, because I want to sort L1. And then I'm going to close the parenthesis, which is to the left of your division sign. So I'm going to close it and hit enter. Now here you don't see anything. It just says, okay, I did that for you. I'm going to go back to stat. go back to edit. So hit enter or hit the number 1 and you'll see that your data is sorted. So there it is. Now, this is your X list, okay? We also need the X squareds. Now you could take each of these numbers and square them manually and put them in here. You could say, okay, L2, you're gonna say that this is 22, you could do that. I suggest that you let the calculator do the whole line for you at once. And the way you do that, does everybody see that my cursor right now is in the first box in L2? Okay.
Yes.
What I'm going to do is I'm going to hit the up arrow key 1 time so that L2 is highlighted. Everybody with me?
Mhm.
Yeah?
Yes.
Okay. So then I'm going to say that after that, I'm going to hit enter. Now, what that does is that should, if I'm doing it properly, and that didn't seem to take place. So what I need to do here is, okay, there it is. It took a minute. It should come down to the bottom of your screen next to the equal sign at L2. And what this allows you to do is it allows you to enter a formula or an operation, okay? What we would like to do is we'd like to square L1. So we're going to, we know how to get L1. We're going to go second, L1. Now you have 2 options if you want to square something. You can either use the squared key, which is it's in about the middle of your calculator, to the left of the comma, above the LOG key. You can use that. That's probably the most familiar one. You can also use the triangle that doesn't have a bottom. It's called a caret, C-A-R-E-T. And you can put the power in that way. Either way will work, but we'd like to square L1. And there's all your squares. So when you do this work, okay, these are the 2 columns of numbers that we want to see. You're more than welcome to let the calculator do this part for you, okay? But you need, on this exam, you need to show us these 2 columns of work, okay? So that's this. I'm gonna stop here for a minute. Does anyone have any questions so far?
This tool came in handy.
Yeah, your calculator is your friend. Sometimes it's your frustration, but sometimes it's your friend. It's supposed to be, but it can be a source of frustration as well. All right, so once we get here, all right, we need a couple of things for our formula. Now, for those who asked about this problem, are you having more trouble with the formula or the calculator, Mauricio?
I was completely unaware of this to the second power and stuff like that. I was just entering the information and it'll just give me the mean, the medium, but I'm like thinking like, oh, okay, what else am I supposed to show like on the homework?
Okay. I will come back to that because you make a good point. And after this exam, you'll be able to go straight there and use that every time. We just need to see. So you can use that as a check and I will come back to that, but that's why I'm going through this part. Let me go through the formula. Let me bring up the, hold on. Let me switch gears here. And I will bring up the formula for the for that particular one. But any questions, any other questions so far about this. Let me bring up 3.2.
So on like on the homework assignment, I'll write a column of L1 and L2 with these numbers.
You can, or you can show the columns the way I did, similar to, hold on. Let me find the screen that was on. Give me a moment. I'm looking for multiple things at once, and that's not my friend at the moment. So
Sorry.
no, that's not a problem. I'm more than happy to answer all of the questions. It's just I can't have everything open at once, but I will address that. So here, here is the PowerPoint for this. And what we're looking at, you're looking at this version. Here she did it with a small data set, okay? So this is similar to what we're doing here. And she shows you the formula here. Now, some students, when they did this, they did the standard deviation first, and then they did the variance. Go ahead and get the variance, because once you get whatever the variance is, you can just take the square root to get the standard deviation. And it's just easier to manipulate the formula. But the formula that we're going to be using involves n, the sum of x squared, and the sum of x quantity squared. Be careful here that you don't confuse let me point it out, that you don't confuse the sum of x squared here. This is the sum of your L2, okay? This is the sum of whatever's in L2. This other term here is whatever the sum of L1 is, and we squared it. Notice where the power is located. Here it's on the inside of the parenthesis. Here it's on the outside. They mean different things, okay? But other than that, the formulas are exactly the same. So what we want, we're going to go back to the calculator shortly, where I'm going to pull up these three numbers. N is how many data values we have. And we're going to pull these two numbers, the sum of x squared and the sum of x, from the calculator, and then put them in the formula to find the variance and the standard deviation. Any questions about this before I take it off the screen? No? Okay. So here, okay, let me do a new share. I'm going to pull up the data here. All right. So what you can do, and Mauricio mentioned it earlier, and you can use this to check your work. There's nothing wrong with that. You can use the stat key, and you can get, you can get the what we call the sample statistics. So what I'm going to do here is I'm going to go to stat. Now, first I'm going to tell me what is L1. So I'm going to say, okay, what I want to do is go to stat, but I'm going to right arrow to calc, and use one var stats, one variable statistics, okay? And I'm going to do that for list one. I don't need a frequency list for this data. You use a frequency list when you have group data, okay? So I'm just going to leave the frequency list blank. Now remember, L2 is already x squared. So I'm going to go ahead and ask it to calculate that for me. And you can see that here, it tells me what what the sum of X is. Okay, so what I'm gonna do is I'm gonna write this on the screen so that we can work with it, all right? So I'm gonna say, excuse me, going to say that N, remember N is, and I'm gonna use a rust color. Let me know if this, sometimes these don't show up well on the screen. N is 12. Is everybody able to see that against the gray background?
Yes.
Okay, all right. Sometimes the colors are not my friends. Now the sum of X is the next thing on here. So I'm gonna go to the sum of X, and again, I can read this off my screen. The sum of X, and I'm gonna use that. Pink is not a good color. I'm gonna, there we go. Sum of X for this is 877, okay? 877 is my sum of X. And my sum of X squared is the one below it, 156,423. So that already added up the X squared column because of what I had in there already. So the sum of X squared is 156,423. Now, 156,423. Now we had the formula earlier, okay? These are the elements that you need for the formula, okay? Your standard deviation is right here. It's SX. 91.6 is there already for you, okay? So if you put this data in the formula correctly, you should get 91.6 as your standard deviation. If you square it, let me put S on the screen because I'll give you the, then we'll be able to check our work when after we do this. So S is supposed to be 91, and I'm gonna write the full answer first. We'll worry about rounding it in a minute. 61625,335. And if I want the variance, I just square this number. Okay, the variance is now going to be on this list. Now, do you feel comfortable, Mauricio, trying this to see if you can?
No, I've done that already.
You did it.
Except that the
You're breaking up a bit, Mauricio. You did that
Yeah.
already, and you did what? I'm sorry, Mauricio, I can't hear you.
Can you hear me now?
I can now, yes.
Okay, I guess maybe I had downloaded two different ones with the whole 12 numbers and the 9 numbers, and I was getting
Okay.
two different answers for, I'm like, okay, what am I doing wrong that I had two different answers? Although the mean was the same, but then the standard deviation, the variance were off.
Well,
like-
yeah, if you have fewer numbers, it will be different.
Yeah, so that's why I was like, okay, wait a minute, what am I doing wrong? So I won't continue because I don't want to keep getting the wrong answers and doing something wrong. But I can see where I'm wrong is that I guess I had on another piece of paper has the 12 numbers and here I only had 9 numbers.
Yeah, the real problem should have
12.
12, okay?
Gotcha.
What can I do for you, Irandi? Did you have a question about something else?
I had a question on homework 3.3.
Oh, okay. Wow. All right, let's take a look at it. I think I have it up here. Let me grab that one so that we can work on that. Find my file here. Thought I had it open, but apparently not. Let me move. Let me see here. File 3.2. Where's my? Let me move some of this open. I'm gonna close a few things. I've got way too much stuff open. Let me scroll down here and bring up the 3.3 homework. Wow. I've got like the queen of screens going on. All right, let's see if this will help me a bit. Bear with me for a minute while I bring it up.
It's okay.
All right, so here is 3.3 homework, measures of position. Is that the homework? No, it's not. It's 3.4. Homework 3.3, here it is. What can I help you with?
For question 8, part C, I kept getting a different answer than the answer key.
All
for
right, question
0.5.
8. Huh? Okay, let's take a look at it and see what's going on here. So,
Oh, there's a typo in that one. It's supposed to be -0.5, not 0.5. It's in the book.
Oh, I didn't see
Yeah,
that.
so you probably got the answer right. It's because it's supposed to be -0.5.
Oh, I didn't. Okay, thank you.
Yep.
anything else? Do you still need to see me do it?
No, I think
Or-
I got it.
Do you have a question about anything else?
Well, I was wondering if you can go over 9.
Sure. From that same,
Yeah, from the same homework.
sure, no worries. We'll hire you all on to find all of our typing mistakes, huh? All right, let's see what number 9's about here. The average weekly earnings in dollars are listed below. Find the percentile rank for each value. All right. So how does percentile rank work? This is a little tricky. This has more than one method. Okay.
Okay.
So this depends on how many data you have. Do you need me to bring up the PowerPoint slides and show you?
No, I have it in front of me.
Okay, all right. So what does let me bring up the homework again. And let's go back. Now, first we have to rank the data, right? So I'm going to, have you already ranked it?
No, I have not.
Okay, whenever you're doing percentiles, we want to rank the data first. So once again, now this data set is fairly small, so we could get away with ranking it by hand, all right?
Yeah.
But if you wanted to put this in the calculator and do what we did before to rank it and then write it in the proper order, that works as well, okay? So, but let's see if we can go through this. So let me annotate the screen. All right, so I'm gonna put it up top. We have a little bit of space. Looks like the lowest value we have is 228. Is that correct?
Yes.
228. What comes after that? 489, I'm thinking.
Yes.
And then we have
524.
524. Okay. And then
597.
597. And then
623.
I see. Oh yeah. 600, yeah, 623. I missed a step. 623. Oops. And then there's the 659, right? Unless I'm missing a number, am I?
No, that's what I got.
659. Let's see here. 659, and then what?
736.
736. And then what?
777.
777, our lucky number. Then
804.
804, and I believe
That's
that
it.
should be all of them. Does everybody agree with that? Are we good here?
Oh,
Does everybody agree?
I do.
Yeah. Okay, this is my data set. Now, what do we do to find the percentile rank for, and you follow a similar procedure, so I'll do a couple of these, okay? But you're literally going to have an answer for every value in the chart. The good news is it's the same calculation every time. So what does it say that we do for the percentile rank?
To divide the, yeah, to divide the distribution.
Okay.
E equals the number of values below X.
Right, so in this case, how many values are below 228?
Below 2. None.
There aren't any. Right, that's always, sometimes students will try to subtract and tell me there's 227. That's not what we're asking you for. It's not the distance from 0. It's the number of values in your list that are lower than this number that you're looking at. So 228 doesn't have any values below it, so that's 0. You add 0.5 to that, and
Yeah.
then you divide by however many values there are. Now, how many values are in the list?
9.
I believe so. Yes, there are 9 values. Okay, so we're going to do a little calculation here, and then you're going to multiply that by 100%. Okay, so go ahead and put this in your calculator. This is basically 0.5 divided by 9. And then you're going to multiply that by 100.
5.5%.
Okay, so let's see. Let me bring this back, new share. So here's what this looks like. We're gonna clear this out. As soon as I get my mouse back, there we go. All right, so we have, can everybody see my calculator on the screen? Did I manage to share the calculator? Yeah, I believe so. So here we have 0 plus 0.5 divided by 9. You're going to multiply that answer by 100, and that's right. So you would round this to however many decimals she indicated. But normally it's 1 decimal place after the decimal. So we have 5.6% if I round it. Okay, so that first one would be 5.6. What would I do for the next number in my list?
The same thing, or
Right, but so in this case, what I'm asking you is, if we go back here, now my rank data, because I was screen sharing and I didn't have it on the actual page, it disappeared. But my second number after 228 was 489, right?
Yes.
So there's only one number in this list below that. Yeah. So in this case for 489, what you would do is you would say, okay, well, there's, instead of no numbers below X, there would now be one number below X. So you would have one number below X plus 0.5. You would divide that by 9.
Okay.
And then you would hit enter. And you would get approximately, oh, and multiply it by 100, right? So you would get 16.7%, okay? You're gonna repeat that for all of the rest of the numbers in your data list,
Okay.
okay? And then there's a second part that asks you about the percentile rank. We'll get to that, but go ahead and work through that first.
Okay.
And then we'll see if we can help you. Giovanna, how can I help you?
Let me try to relocate the. Oh yeah. Homework 3.4 on number 6.
Wow, okay. 3.4. All right, let me pull up that homework for a minute. And I'll be right with you. That's not the right one. Let me. 3.4. How was the lecture on box plots today? Was it okay?
Yeah, it was fine.
Nothing to write home about, huh? All right, let's see. Let me see if I can bring it up. Downloads. There it is. Do you have a question about the actual homework, or do you need something from the slides that you needed some clarification on?
I just needed clarification on number 6.
Just 6, okay. All right, so anything in particular? Were you just lost? Were you like,
Yeah,
okay, I have the numbers.
I
but-
was just wondering if I did it right because my maximum is the same as my upper quartile.
Oh, okay, let me, that would tend to make me suspicious. Let's take a look. Let me make sure I'm sharing the screen here. Otherwise, future watchers will have no idea what we're talking about. All right, so here's our data, all right? Construct a box plot for the following data and comment on the shape of the distribution. All right, so we do all right, so let me bring out our handy dandy calculator here. If I can get the screen to cooperate, there we go. Let me bring up the calculator screen. And let me share here. And let me clear this out. Is everybody? No, I'm still sharing them. All right. Here's let me put my data in a, oops, nope. Let me put the data in a list and we'll see what we can do here. I'm going to do my little trick here. Second, actually, I'll use this since my caption box is in the way. I'll go ahead and use. Okay, my emulator is having issue right now, so let me just see what I can do to make it more friendly toward myself. All right, there we go. All right, so let me see what we've got here. I'm going to clear enter. And I'm going to do the same thing here. Clear enter. All right, so you were saying, go ahead and give me the data from the homework, Giovanna, if you would.
27.
27, you said?
Yeah. Yeah, 2 27s.
2 of them.
Yeah.
Okay, then.
And 2 29s.
Mm-hmm.
3 30s.
Okay. 30, 30, and 30. Uh-huh.
31 and 32.
Okay. All right.
33.
Uh-huh.
And 4 34s.
1, 2, 3, 4. That look good?
Yep.
So there's 14 data.
Yeah.
All right. This is where your stat will come in handy. Mauricio had mentioned it earlier, but it will give you also your help with your box plot. So list 1, calculate that. If we scroll down, minimum is 27.
Mm-hmm.
Now it's telling us the Q1 is 29. We're going to look at that by hand. Our median is 30 and a half. Our third quartile is 34. And our max is also 34.
Mm-hmm.
Okay. So it's probably a reflection of the skewness of the data, is what I would say. But let's do some analysis of the data and see what happens. So what specifically was your question with this? Were you trying to make the box plot?
I already made it. I just got suspicious when my max was the same as
Your third
my
quartile?
yeah.
So just 2 seconds. Stat plot, let's turn it on. Let's make a box plot here. Oops. Not a histogram. Let's make a box plot. And I think, let me try it. Let's see this one. Lex list L1. Okay, I think this is not the right. Let me see. Oh, yeah, okay. Frequency list. No, I think it was this one that we're supposed to use. Okay, and we made our mark. Let's see if this will work. Turn my plot on, because that's the other problem. If it's not going to go on unless I there. Now let's check the window setting. Maybe 10 and maybe 40 here. Maybe scale this by 5 units. Your maximum -10 look good. Your max. Let's try that and see what we end up with. So yeah, what this is telling us is that we have a skewed distribution. So basically, since 34 is our max, we don't have room for a window over a whisker, I should say, on the right.
Okay.
That so it just has a whisker on the left. And if you look, our median is way over on the left. So we're talking about a skewed distribution here, right?
Yeah.
Because if this was normal, then our median, which is this line in the middle of your box, would be in the middle. Now, I think she had something to say about what we call the mid quartile, which is where the middle of this box would be. And the middle of this box would be somewhere here. Let me see if I can eyeball this on the screen. Somewhere
Yeah, like
there,
the
probably,
center.
right? So our median is to the left of our mid quartile, or our mid quartile is to the right of our median, however you want to put that, but that makes this distribution skewed and the median got pulled. That's what's happening here. It's
Hmm.
pulling to the left,
Okay.
okay? So that's, so no, you didn't do anything wrong. It's just a skewed distribution
Okay.
for that. How are you doing, Erlandi, with your percentiles over there? Are you okay?
I got it now. I got the correct answers from how I
Okay,
checked. I got it right. I think I got it.
okay. How about the percentile, the next part of the question?
For
The
for this
number that corresponds to the 40th percentile, I think it said.
was, yeah, it would be 597.
So you did get that to match?
I was.
Good job.
Thank
Okay. For those of you who haven't been here before, Orlandi, I think this is your first time, make sure that you send me your student number in a direct message so I can give you credit for being here. The rest of you, I think I have your student number already. I
In
know
the
I have.
chat or in the Canvas inbox?
You can, no, you can send it in the chat. Just make sure you, when you send the message, send it to me directly,
Okay.
okay? As a direct message. So I can, you guys are welcome to hang out. We still have a little bit of time to be friends for the evening today. Give you a couple minutes if you need it. Does anybody else have anything else that they want to ask? Speak now. All right. Thank you, Orlandi. I got it.
All right.
Okay. Let me stop all the screen sharing here. Yes. Does anybody else have any other questions?
I got a question.
Yes, Jason.
Let me see. It's on 3.1, 3.2.
3.2, okay.
There's so many papers. Also, I did,
I know the feeling.
I also,
Very much.
anyway, I also did number 7 and I got everything right.
Good,
So
good job.
now I know what to do from 4 to, is it 10?
Let me take a look. Because I couldn't swear to that right now. But let me look at it. So 3.2, here we are. Let me bring it up one more time. Zoom meeting. No, that's not the one I wanted. Okay, here we go. So if you can do number 4,
Mm-hmm.
you should be able to do number 5. Number 5, as I said, is 2 data sets, so be aware of that, okay? Number 6, how about number 6?
Oh,
The
I didn't
range
think
rule
of that.
thumb. This is actually a really easy little problem.
Is it just 3?
It's what it is it says use the range rule of thumb to estimate the standard deviation. What the range rule of thumb says is that if you only have a range, and here we only have a range, don't we? We have
Yes.
a range from 26 to 46. What the range rule of thumb says is that the standard deviation, we can approximate that by taking the range and dividing by 4. So to do this problem on number 6, all we have to do is say that S, which is a standard deviation, is approximately, and I'm going to use that little squiggly equal sign that you probably saw in some of your algebra classes, the squiggly equal, right? Means approximately equal to, which is not so great on my screen here, but you get the idea. You take the range and you divide it by 4. So we know how to get the range. The range is the high value, which is 46 here, minus 26. And we divide that by 4. 46 minus 26 is how much?
Hold on. 46 minus 26 divided by 4, 5.
And we're done. That's the range rule of thumb is literally that easy. We can approximate the standard deviation by dividing the range by 4. And the reason this is in your homework is not because she's going to ask you a direct question on this. It's that some of the data sets only have that. So if you ever happen to have a data set that only has the range and you need the standard deviation for some other calculation, you can approximate it this way.
All right.
So
Anyway.
that's how you do that.
So since that's out of the way, my real question was 15.
15. Oh, yes. I believe 15 is a Chebyshev's problem, is it not? Let's take a look at that.
Is it similar to number 6 or different?
Okay, Chebyshev's theorem is a different part of the lecture. And I think, now I could be wrong, but I was talking with Professor Nigdell about this, and I don't think she's covered that yet. I think she's going to cover it separately. But I will cover it. I don't have a video on this problem. I have a video on 16, but I will do 15 here because practice never hurts. Chebyshev's theorem is a particular rule about the distribution of percentages within a shape of a, and some of those rules, like I'm sure you've heard about the empirical rule for bell-shaped curves. Chebyshev's theorem applies no matter what shape you have. So it says, using Chebyshev's theorem, solve these problems for a distribution with a mean of 80 and a standard deviation of 10. So I'm going to write that down so that I don't have to come back to this for a minute. Mean of 80 and a standard deviation of 10. Okay. And if we want to know at least what percentage will fall between 60 and 100. And then we want to know what will fall between 65 and 95. Okay.
Mm-hmm.
So, now when you do a Chebyshev's problem, let me put this on the whiteboard because this is, did you manage to get these problems, Giovanna? Because I know you were working on them last time. Did you manage to get these
Yeah,
done? You did?
yeah. Well, kind of. I was like working on studying it.
Yeah, well, she is gonna go over it, so don't, but I will go over it again here, okay? So what we do when we have a Chebyshev's distribution is I suggest that you draw kind of a number line to keep yourself kind of organized. And we don't know that the distribution is bell-shaped, but for the sake of our purposes here, we take everything, we count everything from the middle, from the mean. So let's go ahead and put the mean in the middle of our distribution. And the mean here happens to be 80. So I'm going to put the mean here in the middle of my distribution, 80. Then it tells me something. Now, when you do a Chebyshev's problem, there tend to be a lot of potential parts and a lot of potential pieces to it. It's like a puzzle. So you always have a mean, you always have a standard deviation, which is S, okay? And then we have this thing called K, which is a number of standard deviations above or below the mean, depending on, you'll see that, and it's easy to get this confused with S, but this is really a multiple of S. So this is going to be K. And then we have some sort of percentage, usually. There's some sort of percentage, minimum percentage that we're looking for, right? And sometimes we have an interval of some sort. So sometimes we have an X min. Sometimes we're looking for that. Sometimes we have it, but sometimes that's generally kind of the things that we're looking for. Now here we have this mean of 80, so we know what the mean is. And we know that the standard deviation is 10. That means they've given us S. So in this case, they've given us 10 here. Now, what that means is we're going to count. We want to know what percentage is between 60 and 100. So I would suggest that since they've given you the standard deviation, that you count back until you find it. So here, you might not know how many this is. This one's relatively easy to count. Sometimes they aren't, but you just want to be able to eyeball this, okay? So I'm going to put 60 right here. And I'm going to put 100 on the other side of 80. This is just kind of visually for you to sort of keep track of what's going on. Now, my suggestion would be, see, we know what S is, right? But in order to find the percentage, and you'll find this in the slides, the percentage, which is what we want, because the first part of this question says, what percentage of values lie between 60 and 80, right? Well, to get your percentage, we know that we're doing P is equal to, now the formula for the percentage here is equal to, let me put it on the board. This is 1 minus 1 over K squared. Okay, so we want to be able to use this formula, but guess what? We don't have K here. In some problems, we have K, but not S. In some problems, we have S, but not K. And this is the case here. We know S, we don't know K. So if you want to know K, which we have to know before we can do this problem, to get K, you can use one of the following. To get K, use either X max is equal to the mean minus KS, or you can use X, sorry, I wrote that wrong. This should be, let me fix that. This is, I used the wrong sign. So to get K, use X max is equal to the mean plus KS. It's a plus, it's larger than the mean. Or you can use X min is equal to the mean minus KS, all right? You don't have to use both generally. They'll give you the same answer for K, and we just need to know what K is. I'll use the maximum here because it tends to give us fewer negatives to work with. So the maximum in our interval for part A is 100. The minimum is 60. Any questions about how I set this up so far? No? Okay, so X max is 100. 100. Now what is my mean?
The mean is 80.
80. What is my K? I don't have it. And so that's just going to be
No.
K. How about S? What is S?
S equals 10.
S is 10. Very good. Now this is our nod to algebra. Okay. So we do a little algebra to solve for K. Do you think you can do that algebra for me, Jason?
Okay.
It's not as hard as it's not as hard as it looks, I promise.
So 100 equals 80 plus K10.
Okay. And I want to solve for K. So what should I do?
Okay, so okay, this is easy. What you're gonna do is you're gonna subtract the 80 and put it to the other side.
Yeah, so we're going to start by subtracting 80 from both sides. 100 minus 80. Okay. And I'm going to subtract 80 from the other side. So I'm going to write 80 minus 80. You can also write it underneath. I tend to write it on the same line to save space, but you can certainly write it underneath if you feel more comfortable doing so. But I'm going to write 10K instead of K10 because 10K probably looks a little more orthodox. All right. So this is my equal sign. So 100 minus 80 gives us what?
40.
Mm,
No, wait, no.
no, 100 minus 80 is 20, right? And
yeah.
then I have 20 is equal to 10K. So what does that mean K is?
That means we have to divide it.
Right. Divide by 10 on
Divide by
both
10.
sides.
K equals 2.
Very good. So what is this saying to us? This is saying that, oops, let me get this correct. 20 divided by 10 is equal to 10K divided by 10. And so that means that 2 is equal to K. This, now let me try and explain, because this is the hardest. The formula, once you get this, is easy. The formula is not usually where people get stuck. It's what's going on with this 10 and this 2. If you remember, I told you to make marks and think of counting back by, remember the standard deviation was 10, right? So if our mean is 80 and I'm going backwards 10 units, that's 70, right? I went back. So from here, from 80 back one standard deviation was 70. And 70 back one standard deviation was 60, correct? So
Mhm.
between 60 and 80, we have a total of 20, right? There's an interval of 20, but how many multiples of the standard deviation did I go?
2.
2. That's what this K represents. The number of standard deviations above or below the mean. It has to be the same. So here, this is 90 here. So this is going to be 90 would be here, for example. And again, this picture is just to help you see it, but that's the difference between the standard deviation S and K. So we know K is 2, right? So now let's do our calculation. And if you've got the percentages memorized from the slides, if not, that's okay, but it will help you. This is 1 minus, remember, K was 2, so you have 1 minus 1 over 2 squared. Okay, so remember, square the 2 here. So 2 squared. 2 squared is 4, right? So we have P is equal to 1 minus 1 over 4. And if you put that in a calculator, you'll find out that you get P is 0.75 or 75%. So
Okay.
about 75% of this data is between 60 and 100. Okay, that's part A. Now part B is similar, okay, but we're going from 65 to 95, okay? So the procedure is similar. S stays the same, but your K will be different. So you'll have to recompute K for this problem, and then you'll find S. I'm sorry, find P after that. You already have, you can depend on S being the same. That will stay fixed. But you're a little bit closer, because now for part B, your values are going to be like here, from here to here. Okay, so you're a little bit closer to that middle line than you were the first time. Okay, so what we need to do is figure out what K is. So we're going to use that same idea, but remember part B has a different interval. Try it and see what you get. Did you have a question, Giovanna, about this?
I had a question on, it's a quick question. I had a question on 3.1.
Oh, okay.
Number 15.
15, you said?
Yeah.
All right. Jason, can I stop sharing the whiteboard while you try part B?
All right.
Do you still need it? Are you okay?
I'm good.
Okay, I'm gonna stop sharing that. And I'll be back with you in a few minutes. Let me check on 3.1 here. Let's see. Let me close a few things here. And I think this is 3.2. That's not what I want. All right, let me stop sharing the screen. Go down here to, I should have everything open. Here it is, 3.2. 15, you said? Or 3.1, you said, right?
Yeah, 3.1.
3.1. I was like 3.2 was what we just, let me see. Is this it? Let me see what this is. No, that's 3.2, isn't it? What section is this? Okay, this is, hold on, I've got the wrong. Bear with me for a second here. I have to find the right. I think I've got 3.2 open twice is what it is. Yeah, I do. Let me find 3.1 again and see where we are. We do this like this, down. And we're looking at 3.1. Here it is. Okay, 3.1, number 15. Oh, okay. Which one of the measures of central tendency would we use for the given situation? So what do you know about which situations require which measures? Anything stick out to you?
I know that for mode, it's the number that appears the most.
Right, so it appears the most. What about the mean and the median? There's a significant thing to both of those.
I know median would be like the average.
Okay, so the mean and the median are different ways of finding averages.
Oh, I mean
Well,
the mean would be the average.
What we typically think of as the mean is what you guys, if you came in with any knowledge of statistics at all, usually mean is the one that people have picked up because you've calculated an average at some point in your life, a grade point average, which is actually a weighted mean most of the time. Sometimes it's a straight mean, but sometimes it's weighted. But that's usually the one that's the most familiar. Coming into it, the median is a kind of an average as well, but it tends to be what we call more robust. And that just means that if there's extreme values in the data that would tend to pull the distribution and cause a skew like we saw before, that you're going to have more resistance. The median will be more resistant. Now, why is that? If you think about how the median is calculated, you take out the low and the high values until you get to the middle number, right? So if you have extremes, you're throwing out those extreme values, okay? And so the median tends to be resistant to those extremes because they tend to not enter the calculation as much, okay? So for these situations, state which measure of central tendency should be used. The most typical case, that's the one that repeats the most.
Yeah.
So that would be what?
Mode.
The mode. If the distribution is open-ended, meaning if we don't have a maximum point for that, then we would want a median for that because we don't know where this ends, but we would want to take whatever we had and get the extreme values out of it and find a middle number. So if your distribution doesn't have like a max or a min, and what that means is like, we have something like it'll say 0 to 10, 10 to 20, and then it'll say 30 or more, for example, right? We don't have a maximum. The median will be a better option in that case. Okay. If there is an extreme value in the data set, what do you think about C? I kind of gave this away earlier. If there's extreme values in the data, and we want a better answer for the average, what should we use?
A median.
The median, because the median is more resistant to those extremes, okay? How about D? The data are categorical. Do you remember what categorical means?
Yeah, categorical means like there's not really a number on it.
Okay. If I went around and I did a survey and I was asking all my students that come to tutoring, what is your favorite ice cream flavor? Chocolate, vanilla, strawberry, or something else,
Mm-hmm.
right? That would be categorical data, right?
Yeah.
What would be the best measure of the center for that? What kind of thing would I want there?
Mean.
Well, how can I get a mean if it's not numeric?
Oh, well, mode then.
Mode, right? It has to be, think about how you get a mean. How do you get a mean normally?
When like something appears more than one.
No, you're mixing them up. So the mode is the one that appears more than
Oh,
one.
never mind. The mean is like the average.
Right, so let me ask this another way. If I wanted to calculate the mean, how would I do it?
You'd have to hold on. I have to look in my notes.
That's fine. I'm looking to
Oh,
calculate.
you'd add up all the numbers and then divide by the total number of values that there
Right,
are.
so let me ask you this question. That's how I do it, right?
Yeah.
But if I had data on students' ice cream flavor,
Mhm.
how would I calculate the mean of that?
You can't because it's not numerical.
Right, it would be, I would have to do what we call code it and make like every number one would mean chocolate, every number two would be, I could do something like that, but it would still represent a category, not.
Yeah.
So I can't get a mean from categorical data, you see?
Mhm.
But I can get a mode from categorical data. And that's what I would do in that case. I would
Standard
look for a
deviation.
mode
Mhm.
situation. Okay, Jason, did you have a question?
Hold on, I'm just finishing up another question.
No problem. Okay, how about E? We mentioned this earlier briefly, but yeah, you might not have caught it. I snuck it in when Mauricio was here. Further statistical computations will be needed. What would I want to use in that case? If I was going to use the mean or the calculation for something else, what would I want to have? Think about some of the other calculations you've done, like the standard deviation, the variance, right?
Mhm.
What kind of measure do we usually have that's in, think about the big formulas that you've seen, the
Yeah.
big hairy ones that we tell you, you don't have to use that.
Yeah.
What do they have in it usually?
They usually have the mean.
Yeah. So if you're going to use a statistic, if you're going to do further statistical computations, the mean is a good thing to get because you can get a lot of other things from the mean. It's kind of like that all-purpose food in your kitchen, whatever it is for you. For some people, it's rice. For some people, it's potatoes. For some people, it's chicken, like 500 ways to make chicken, whatever it is. The mean is kind of your all-purpose statistic because you can use it to get other things, okay? And F is pretty much self-explanatory, I think.
Yeah.
The
I got
values are to be divided into two approximately equal groups, one group containing larger values and one group containing smaller, that's the median. Okay, so. Good job. Nice little discussion. This is also on in a little bit less detail than I went over. This is also in the 3.1 summary video that I did.
Okay.
So now it'll be on here too, so you can watch it twice. Coming to a channel soon.
Thank
This-
you.
You're welcome. Thank you for staying. Thank you for finding our typos. Take care.
You too.
Jason, are you about done?
Yeah, I just finished questions 7 and 8.
Cool. Are you feeling okay with the Chebyshevs that we went over, the second one?
Yeah, the one about 15, the one on 15.
Yeah, the second part of it, the one I left you doing when I was helping Giovanna.
Yeah, I got 56%.
So you got it to work?
Yeah.
Good deal. All right, well, I have to say good night for tonight,
All right.
but you're welcome to join us again tomorrow
All right.
for more fun and good times. And give me a little time to get some of this posted, but we should have something out for you, okay? And look for a lecture from Professor Nick Dell on the Chebyshev's theorem. And if she asks me, I'll put up some more about that. I'll check into it.
All right.
Okay?
Mm-hmm.
All righty,
Thank you.
take care. You're very welcome. Thank you for coming.
All right.
Bye now.
Goodbye.